Hey everyone, I got another application problem here for you. In this problem, it says assume that in 2003, consumers used credit and debit cards to pay for 38% of all purchases. So 2003, 38% of people were using credit and debit cards. This percentage is projected to be 58% in 2011. Find a linear function that models the data where x is a year and p of x is the percentage. So really, when we read all of this, there's only certain things that pop out to us. 2003 and 38%, 58% in 2011. Linear function we need to write. And x is the year, p of x is the percentage. So we underline the things that we know, and now we're going to go through and we're going to break this down. So what is a linear function first? Linear function is obviously a straight line on a graph, and a linear function is going to be some sort of equation. And so how do we write an equation? Well, typically we're going to use point-slope form. So point-slope form is where I'm going to start. I'm going to say y minus y1 equals m x minus x1. But in order to use point-slope form, I need some data points. Well, do they give us data points in the problem? Sure, 2003 and 38%. And obviously 2003 dictates the percentage because you can see here the percentage went up because the year changed. So whenever the year changes, that dictates the percentage. So the years, which is 2003, is going to dictate the percentage. And I'm going to write it as a decimal, which is 0.38, just for this problem. I just think that it's better to write percentages as decimals when you write equations. And then 2011, our other data point is 0.58. So then we can go through and we can use point-slope form to find our slope. So that's what we're going to do. We're going to find the slope, and then we're going to take the slope, plug it into the equation, along with one of these points, and we'll have our linear function. So we plug in, let's see, 0.58 minus 0.38 is going to equal m, and then we're going to have 2011 minus 2003. And then we have 0.58 minus 0.38, which is 0.2. And then 2011 minus 2003 is 8. So now I'm going to divide by 8, and I'll get 0.20 divided by 8 equals m. I don't like how this is written with a decimal above the fraction, so I'm going to multiply this by 10 over 10. And I only multiply this by 10 over 10 because this is the tens place. And because this is the tens place, if I multiply by 10, I'm going to get a whole number. So that's going to give me 2 over 80, which I can then write as 1 over 40. So my slope is 1 over 40. I hope that makes sense why I multiplied by 10 over 10, because 0.2, that's the tens place, and I don't like 0.2. I don't like a decimal inside of a fraction, so I'm going to get rid of that decimal by multiplying by 10. I'm going to take this now and I'm going to use point-slope form. So I'm going to say y minus y1, which I'm going to use this coordinate. So I'm going to use this as my x1 and my y1. And I'm going to use the slope. So y minus 0.58 equals 1 over 40, x minus 2011. So you can see I've got an equation now in point-slope form. They wanted us to write it. They wanted us to write a linear function. We wrote the function. This is a linear function and point-slope form. Now, before I get too carried away here, let's go ahead and then we can circle this. And now we can look at part B. It says estimate when this percentage was 43 and 53%. So they're asking you to take this and estimate when it's 43 and 53%. Well, I can actually rewrite this as the percentage of x for y minus 0.58 equals 1 over 40 x minus 2011. Remember, you can, with linear functions, you can substitute y for function notation, which is this would be the percentage with an input of x as our year. So So then remember, 43 and 53%, they want us to make estimates. So I'm going to figure out basically when the years, when is it going to be 43 to, or 43 to 53%. So what I'm going to do is I'm going to say, all right, I want to check P of 0.43, and I also want to check P of 0.53. So if I do P of 0.43, that's going to equal 0.43 minus 0.58. Actually, I don't like how I'm writing this, and I'm going to run out of room. So I'm going to write this underneath. So I want to find P of 0.43, and that's not exactly, I really botched this, guys. I'm not plugging 0.43 in for X, right? 0.43 is actually the percentage. I need to plug 0.3 in for here, not for X, because that would imply that that would be the year. I want to plug 0.43 in for P of X. So I'm going to say, instead of these two things I just wrote, I'm going to cross these out, and I'm going to say, all right, P of X equal 0.43. And I'm going to say P of X equals 0.53. And I want to check those. Sorry for that little mistake. So I'll plug 0.43 in, minus 0.58 equals 1 over 40, X minus 2011. And when I subtract this, I'm going to get negative 0.15 equals 1 over 40, X minus 2011. I'm going to multiply by 40, because if I have a fraction, I can multiply each side by 40. And when I do that, I take 40 times 0.15, and that's going to be negative 6 equals, that'd be 1. Well, actually, when I multiply 40 by 140, by 40 by the fraction 1 over 40, that's going to give 1, so I can just write X minus 2011. So now I can add that to the other side, and I end up with X equals 2005. Now, if I do the same thing over here, that's going to give 0.53 minus 0.58 equals 1 over 40, X minus 2011. That'll give negative 0.05. I'll write that better. Negative 0.05 equals 1 over 40, X minus 2011. I'm going to multiply each side by 40, just like I did in the previous problem. And when I do that, that's going to give 0.05 times 40. So that's going to be negative 2 equals X minus 2011. Remember, I'm just multiplying this by 40, becomes 1, so that's the only thing that's written there. That's the only thing that's left. So then I'm going to add the 2011 over, and that's going to be 2009 equals X. So it asks you in the above problem for part B, if we go back up, says estimate when the percentage was between 43 and 53. Well, that clearly is from 2005 to 2009. So I'd write 2005 to 2009, and I'd say 0.43 to 0.53, and circle that answer.